In this video, we'll be exploring the concept of functions and relations. Now, some of the questions that we'll be answering today includes: what are functions and relations? How to evaluate function-based questions? What are inverse and composite functions? We'll be also looking at how to evaluate those types of questions. Now, if you haven't yet subscribed to this channel, please take this time out to do so. Alright, so I want to look at the whole concept of relations and functions, alright? But let's start off with relation. So a relation is any set of ordered pairs, alright? For example, here we have -2, 6. So this parentheses right here is considered to be an ordered pair, alright? A key thing to note, down here an ordered position right here. So we normally separate the x-coordinate at the front from the y-coordinate using a comma right there, and we have them in parentheses or brackets. So this is an ordered pair. So we can also use some numbers here. So if we have 1, 2, so this is an ordered pair. So all a relation is a set of ordered pairs. So we have a group of these things, as you can see here. So, and we have a set notation to demonstrate that. So we have a set of these things. So we have 4 ordered pairs in this particular set. So here we have -2, we have 6. So the -2, all the numbers or values that comes at the front are the x-coordinates, all right? So all of the numbers or values at the front are called the x-coordinates. So we have -2, 8, -9, and 4. All of these are the x-coordinates. And here we have the y-coordinates, which we also refer to as f of x, all right? So y and f of x, same thing, all right? Key thing to note, especially when dealing with function. So 6, 4, -3, and -5 are all our y coordinates, all right? Which we also refer to as f of x, all right? So this is pretty much what relation is all about. A relation is any set of ordered pairs, and as we outlined down here, an ordered pair is just a composition of the x-coordinate and the y-coordinate that we normally have these things in parentheses, all right? And this is how we set them up. Now let's look at the concept of functions. A function is a special case of relation. And what many of the times you will hear about these things is that all functions are relations, but not all relations are functions, all right? So a function is a special case of relation. A function is a relation that can either be a one-to-one or many-to-one. Functions can be represented as, we can represent functions in equations, and we can also represent functions using mapping, all right? And this mapping, we refer to this mapping as a one-to-one, all right? So we can have a one-to-one mapping or many-to-one mapping to represent a function. This is a one-to-one. So the x values are only mapped to one y value. All right. So the x values are only mapped to one y value. We refer to that as a one-to-one. So here we have the x value, which is 4, only mapped to the 9 over here, which is y. And this is the function that represents this mapping right here. So this pretty much means, and another thing, another word that we use to refer to the x-coordinate is the input. We refer to the y as the output. So if we should substitute 4 in this function, 2 times 4 would have given us 8 plus 1 give us our f of x, which is the same thing. Again, f of x is the same thing as y, which gives us our y value here to be 9. All right, so I hope you were able to see that. So if we substitute 4 in this function, 2 times 4, so we would have replaced x with 4. 2 times 4, that's 8 plus 1, that's 9 right there. And again, if we substitute 5 in this thing, 2 times 5, that's 10 plus 1, 11, all right? So this is what we call a one-to-one mapping. Now, a many-to-one mapping simply means that we'll have more than one x values being mapped to one y value. All right, so we could have had this 4 over here and this 5 over here being mapped to this 9 over here, depending on the function that you have and that you're treating with. All right, so we can have a 1-to-1 mapping or a many-to-1. Now we also represent functions using ordered pairs. All right, and as I explained previously when we were looking at relations, an ordered pair we have is a composition of the x coordinate and the y coordinate, all right, which we refer to as f of x also. All right, the reason why I continue to repeat that, it is very important, all right, when treating with functions to understand that f of x and y are the same thing. All right, so here we have the x coordinate and the y coordinate there, 5 the x and the y coordinate there, and again we use this particular function to obtain these values. All right, and we can represent the equations of the function. We can have y equal to x plus 1, and again f of x is the same thing as y, so f of x is equal to 2x plus 1. We also represent functions using, well, these are the normal form that it takes. So normally you see either y equal to some function or f of x equal to some function or g of x being equal to some function or h of x. All right, so these are normally the ones that we normally use. All right, now we are going to look at how to perform calculations, all right, when it comes to functions. All right, now let's say we have a question. All right, so given that f of x is equal to 3x minus 5, determine the values of these things right here. So f of 2, f of negative 4, f of 0. All right, so let's start off with f of 2. So let's say we want to find what f of 2 is. Now what we want to do is to recall the function. So that's very important because it is the function that we'll be using to solve these things. All right, so remember the function. So the function is defined by f of x equal 3x minus 5. All right, so if we want to find f of 2, what we're going to simply do, wherever we have x, we're going to substitute 2 right there. All right, so we're going to replace the x with 2. So here we have 3 and would have had the x. Instead of writing back the x, we are going to replace the x with 2 minus 5. So 3 times 2, that's 6. And we'll put back the minus 5 right here. 6 minus 5, that's 1. All right, and that would have been our solution for the first question. Now let's look at the second one, which would have been what? F of negative 4. All right, so we're trying to find f of negative 4 now. So f of negative 4, and this is Roman numerals 2. So we're trying to find f of negative 4. And again, remember the function f of x is equal to 3x minus 5. So this is what we're using to solve the thing. So we want to find what f of negative 4 is. And again, we do the same thing. So it's very easy, all right? So we have 3. Wherever we have x, we'll replace x with the negative 4 right here. Minus 5. So 3 times negative 4, that's negative 12 minus 5. So negative 12 minus 5, that will give us a negative 17 right there. And in this case, this would have been our solution. Now let's look at, I believe the final question would have been f of 0. All right. So I want to find what f of 0 is. That's Roman numeral 3. So f of 0. All right, and again, recall our function f of x is equal to 3x minus 5. I want to find what f of 0 is. All right, so we'll have 3 wherever we have x, replace x with 0, minus 5. So we'll have what? 3 times 0, that's 0, minus 5. 0 minus 5, that's negative 5. All right, and that's pretty much how you treat with functions. Now we want to look at both inverse functions and composite functions. What are these types of functions and how do we perform calculations involving these two types of functions? Now let's first look at inverse of a function. Now the inverse of a function does the opposite of the original function. Alright, for example, let's say you were getting dressed, alright, and we are just talking about your sock and your shoe now. Now, when you're getting dressed, the first thing that the original function would have been, you put on your sock first, then you put on your shoe, alright? So the original function would have been sock plus shoe. Now, the inverse of that would have been the opposite, which means when you would have been getting undressed. So when you're getting undressed, then you will take off your shoe first, then your sock. Alright, so the inverse of the function does the opposite of the original function. Alright, so that's simply what inverse of a function is talking about. We represent inverse of a function as f inverse of x, g inverse of x, h inverse of x, etc. Alright, and this negative, just g to the power of -1 simply means inverse. Alright, so f inverse of x, g inverse of x, h inverse of x, etc. Alright, now we're going to look at some questions involving inverse of a function. Alright, let's say we had f of x being equal to 2x plus 4. Alright, and we want to find what f inverse of x was. Alright, and again, as I explained before, it is very easy to find the inverse of x because the inverse of the function pretty much does the opposite of the original function. Alright, so if we have the first thing that we see is that what? We have a x, alright, and the things that are going on here, we do what? We say that we multiply the x by 2 and then we add 4. Alright, so that's what we see taking place here. Alright, now if we should do the opposite now, what we'll do first, we'll start from here. So the opposite of adding 4 is to minus 4. And whatever we have, we're going to divide by 2, alright? Because multiplying by 2, the opposite of that would have been to divide by 2. So this is what the inverse of the function would give us. Alright, so the inverse of 2x plus 4 will be what? We'll have x minus 4 and we'll divide that by 2. And that's how we can obtain the inverse of the function. However, your teacher won't accept this thing, alright? So they want to see the working for everything. That's what maths is all about. So we're going to look at how to find the inverse of a function using calculations and not this shortcut method, alright? So this is just to establish that the inverse of the function is simply the opposite, or does the opposite of the original function. So again, the function that we had here was what? F of x is equal to 2x plus 4. Alright, so we want to find the inverse of this thing. Now what we're going to do, again, remember, the first thing we're going to do is to let f of x equal to y. Alright, and again, if you recall what I've explained previously, f of x is the same thing as y, alright? And y is easier to work with than the f of x, alright? So that's why we choose to use y here. So instead of having f of x being equal to 2x plus 4, we are going to replace f of x with y. So y is equal to 2x plus 4, alright? So that's the first part of it. So we'll let f of x be equal to y. Alright, now the second step that we're going to do is to interchange. Alright, so we're going to interchange x and y. Alright, so we're going to interchange x and y. That's what that simply means. Wherever we have x, we're going to put y there. Wherever we have y, we are going to replace the y with x. Alright, so here we have a y, we are going to replace the y with x is equal to 2, have the 2 there. Here we have the x, we are going to replace the x with y. Alright, plus 4. Alright, so again, we interchange x and y. So wherever we have y, we replace the y with x. Wherever we have x, we replace the x with y. Alright, so that's what we did right there. Now, what we're going to do next is to now make y the subject, all right? So we're going to make y the subject of the equation. All right, so we're going to make y the subject of the equation. So that simply means we're going to transpose for y. Hopefully you understand those terms, all right? What this is talking about, we want to have y on one side of the equal sign by itself, all right? So that's another way how we could look at it. So here we have x is equal to 2y plus 4. And I just rewrote that thing right there. So what I'm going to do is to transpose this thing. And whenever we're transposing, we're simply doing the opposite of the operation that is taking place. All right. So to remove something, you must do the opposite of the operation that is taking place. And the key thing about equations, you always want the equation to be balanced. So whatever you do on one side, you must do the same thing to the other side. All right. So that's a key thing to note. So because we want y on one side by itself, the first thing we're going to get rid of this 4 right here. All right, so that's the first thing. But if we want to get rid of a positive 4, we have to do the opposite, as I mentioned before, which would have been minus. But if we're going to minus 4 on that side, we need to minus 4 on this side as well. So minus 4 over here, we have 2x plus 4. We're going to minus 4 over here as well. All right, so that's how we can get rid of this 4 right here. We'll do the opposite of the operation that is taking place. So 4 minus 4, these things pretty much cancel or eliminate each other. So we're left with x minus 4 being equal to 2y. All right. And now what we want to do is to get rid of this 2. So we have 2 times y. So we need to do the opposite of this operation. And the opposite of multiplication is division. So we'll divide both sides by 2. All right. And we have to do that to keep the equation balanced. So we'll multiply both sides by 2. So we'll be left with x minus 4 over 2 being equal to y. All right. And what we got for y, that's the inverse. So therefore, f inverse of x would have been equal to x minus 4 over 2. All right. As I demonstrated before, so that's what we got right here. So the inverse of a function does the opposite of the original function. All right. So that's how you go about finding the inverse of a function. That's what it's all about. All right. And I'll be creating more videos on solving the inverse of a function in my CSEC segment on Thursday, God willing. All right. So you can look out for that video. So that's pretty much what the inverse of a function is all about. Now let's look at composite functions, all right? So a composite function is a combination of 2 or more functions. So for example, this is how we normally represent a composite function. We can have f of g of x, g of f of x, h of f of x, h of g of x, etc. All right? So we can have, so it's a combination of 2 or more functions, and we'll look at how we perform calculations involving these things. All right, now let's look at an example of how we treat with composite functions, all right, as it relates to calculations. All right, now given that f of x is equal to 2x plus 3 and g of x is equal to 5x minus 4, determine a f of g of x, b f of g of 2. All right, so they want us to find the function for f of g of x here, and once we obtain this function, then part b will be like a piece of cake. All right, so all we'll be required to do in part b is to substitute 2 in the function that we would have obtained in part a. All right, so how do we go about finding f of g of x? All right, what we're going to do is to actually substitute the g of x function into the f of x function. So remember the f of x function, we had what? 2x plus 3. So we have 2 Now, wherever we have the x, we're going to replace the x with the g of x function. So we'll substitute 5x minus 4, this entire thing. So we are going to replace the x with 5x minus 4. And then we'll add back the 3 out here. So plus 3. All right. And this is pretty much the f of g of x function. All right. And we can simplify this thing. However, this is acceptable because if you actually substitute 2 in this thing, you'll obtain the same result. But if you expand this thing, it's probably easier to work with. So you can expand this thing if you so choose to, all right? Now, if we should expand this thing, we'll obtain 2 times 5x, which is 10x. 2 times negative 4, that's negative 8. And we add the 3 out here. So this thing is the same thing as 10x, negative 8 plus 3, that's negative 5. All right, and that would be part A. So this would have been the solution for part A to obtain this function. So f of g of x is just 10x minus 5 if we choose to simplify it. All right. So by simplifying it, then it makes part B a whole lot easier. So part B now, so this is part A, solution for part B now. So the solution for part B now, so here we would have had now f of g of 2, all right? So recall the f of g of x function that we just found, that's what, 10x minus 5, all right? And we can now substitute wherever we have x, we'll replace that with 2. So 10, replace the x with 2 minus 5. So again, the bracket symbolizes multiplication. So 10 times 2, that's 20 minus 5. So this is the same thing as 20 minus 5, which is 15. And this is pretty much how you treat with composite functions, all right? That's where we'll end today's video. If you haven't yet subscribed, please do so, and don't forget to share this video. All right, thanks for watching.